This is our group for the group project. My name is Natasha Horonenko.
My name is Marissa Hart.
And my name is Daisy Baldwin.
Alright, so problem number 59, and that's a 40 grams of molten iron 2 oxide reacts with 10 grams of magnesium. What's the mass of iron produced? So your equation is iron oxide liquid form plus magnesium in liquid form reacts and forms iron in liquid form plus magnesium oxide in solid form. So first you have to do your given, which is 40 grams of FeO, and you're trying to cancel out the grams of FeO, so you know 1 mole of FeO is equivalent to the molar mass, which is 71.85 grams over moles of FeO times 1 mole of Fe, since we're trying to go from FeO to Fe, over 1 mole of FeO times the molar mass of Fe, which is 55.85 grams, over 1 mole of Fe. And these will cancel out. Your moles of FeO will cancel out, and your mole of Fe will cancel out, so that you're left with the grams of Fe. So when you do this, you're left with 31.1 grams of Fe. Alright, so next you have to figure out how much iron is produced with the amount of magnesium given. So you're given 10 grams of magnesium, and you have to multiply that by 1 mole of magnesium over the mass to cancel out the grams, and the mass of magnesium is 24.31 grams. And then you have to multiply that by your moles to cancel out the moles. So you have 1 mole of iron, since that's what we're trying to figure out, over 1 mole of magnesium. And then to cancel out the moles of iron so that you're left with the mass of iron, you do the mass of iron, which is 55.85 grams, over 1 mole of Fe, and you're gonna be left with 23 grams of Fe. So then you have to compare the two numbers that you got. So for FeO, it produced 31.1 grams of Fe, and magnesium produced 23 grams of Fe. And since the 23 is less than the 31.1 grams, you know that magnesium is your limiting reagent. And your equation produced 23 grams of iron.
Alright, so I had problem 61, and the question is, if 175 grams of molten iron 2 oxide reacts with 37.5 grams of aluminum, what is the mass of iron produced? The equation is right here, and it's Fe2O3 in liquid form plus Al in liquid form reacts to Fe in liquid form plus Al2O3 in solid form. So first off, we're gonna have to balance our equation because this is not balanced. So to do that, we're gonna have to do Fe2O3 in liquid form plus 2Al, because that's gonna balance the other side, in liquid form, reacts to Fe in liquid form, and then we're gonna have to add a 2 in front of the Fe because now it's balanced, plus a L2O3 in solid form. Alright, so now that our equation is balanced, next off we're gonna have to take our 175 grams of molten iron 2 oxide. So 175 grams of Fe2O3, don't forget the grams, times 1 mole of Fe2O3 over the molar mass of molten iron 2 oxide, which is 159.70 grams Fe2O3 times 2 moles of Fe and 1 mole of the Fe2O3, because we have to cancel out the mole, times the mass of iron, which is 55.85 grams Fe, because we're going to want to end with this, over 1 mole of Fe. So all of these cross cancel each other out, which is equal, and this equals 122 grams of Fe. Okay, so now that we're done with the first equation, we're going to do our second one, which is this 37.5 grams of aluminum. So 37.5 grams aluminum times 1 mole aluminum. And then we're going to have to take the mass of aluminum, which is 26.98. So 26.98 grams aluminum, times that by 2 Fe, so we cancel out our moles. So 2 mole Fe over the 2 moles of Al, and then we're gonna have to times that again by the mass of iron, which is 55.85. So 55.85 grams of Fe, because this is what we want to end with, over 1 mole of Fe, so we cancel our moles again. So this mole of Fe is going to cancel out with this, Al is going to cancel out, and grams of aluminum is going to cancel out with grams of aluminum, and once we solve that equation, we are left with 77.6 grams of Fe. Okay, so those two solutions we got is 77.6 grams of Fe and 122 grams of Fe. Since this is a smaller number, 77.6 grams of iron is the amount of iron produced, and aluminum, or Al, is the limiting reagent, because when you compare the two numbers, it produces the least amount of iron. So you're always going to want to take the smaller number to get your limiting reagent.
So my problem is number 69. It's if 70 milliliters of nitrogen gas react with 45 milliliters of oxygen gas, what is the volume of N2O3 produced? Assuming that all gases are the same temperature and pressure. So in here you have 2 oxygens. Over here you have 2 nitrogens and 3 oxygens. So the oxygens don't match up. So you have to get the greatest common factor. So, which would be 6 in this case. So over here, in order to get 6, you're gonna go ahead and put a 3 here. And then in order to get 6 on this side, you're gonna put a 2 here. Now this makes the nitrogens on both sides not balanced. So you have 4 nitrogens here and 2 over here. So to make it balanced, you put a nitrogen here, 2 nitrogens here. So from there, you get your given, which is 70 milliliters of N2. And then from there, you're gonna do the molar ratio, which is 2 milliliters of N2O3 over 2 milliliters of N2.
you're not really gonna do much of conversions just because it's already in milliliters and you're just going to the milliliters of the N2O3. So from here, you're gonna cancel these out, the equations, and then from there, 2 divided by 2 is already 1. So from here, you're just gonna have 70 milliliters of N2O3. And that's your answer for that part. So for 45 milliliters of O2, that's your other given. So from there, you're gonna go ahead and multiply 2 milliliters of N2O3 over 3 milliliters of O2, because there's 3 O2s here, and then there's 2 of the N2O3 here. So from here, you're gonna go ahead and cross cancel these. Okay, so from here, you have 45 milliliters of O2. You're gonna multiply it by 2 milliliters of N2O3. It's gonna give you 90. Divided by 3 is gonna equal to 30 milliliters of N2O3. So after comparing the two results, it's clear to see that oxygen is the limiting reactant, so therefore only 30 milliliters of N2O3 can be produced.